the camera a little bit, but this is Travis with Reef Power Maui.
Hello, everyone.
Hello. That's Simon's family.
Look familiar things.
Okay, so my name's Travis Liggett, and when I say I'm president of Reef Power, it's just me, a researcher who's trying to find a solution to the injection wells. But if you go to the first slide, I'll just start with a little bit of history about where I came from and why I'm here talking to you about a solution to the injection wells. I grew up in Indiana on a river called the Mississippi, and when I was about 8, I started getting sores all over my body. And we found that we did a dye test, and my uncle's septic tank was going into the stream. And next door, the trailer park, I never noticed before, there was a pipe that just went into the air, into the river, right in the stream. So I became so sick that my family had to move. So we talked about Batman. Wastewater is my bats. This is my trauma, and this is what I really wrapped my life around. So next slide. In 1983, when I got sick and we had to move, we randomly came to Maui, and I went to Black Rock and swam in the reefs, and it was just such an experience that the whole world wasn't there. I was like, wow, there's somewhere pristine, and I really said, I'm gonna devote my life to like ecological water issues. So. I went to school, I studied aerospace engineering, and got into ecological closed life support systems. What that is, instead of taking machines and huge amounts of consumables in space, you take the species that you need with you that can regenerate and recycle your resources for you. So I kind of went along that path. I always thought it was plants was going to be the solution, because I thought photosynthesis and water have to go together. But in 2007, at Burning Man of all places, I saw an exhibit about algae. And I was like, wow, this is it. I worked at a project at NASA and ended up coming here. The sole reason I came to Maui was to try to solve this problem. That idea was a terrible idea, and I've since evolved into the idea I will tell you about today. So that's the long story of how I got here in front of you right now. So the injection wells, there are 3 municipal facilities, Kihei, Kahului, and Lahaina. It's about 10 to 13 million gallons a day that goes into the ocean and the groundwater. This is what an injection well plume looks like. Now, underneath the subsurface of all this lava is salt water that permeates the ground. So when you inject fresh water in, it's less dense, so it floats on the salt water, kind of floats right on the groundwater out to the ocean. So that's what's happening. And this is the visualization of the plume in Kihei. It's about a mile wide. It's about 2 million gallons a day in addition to the 3 million gallons a day of groundwater. So it's pretty much doubling the groundwater. This is another visualization of the plume, and you can see these red dots show that the Limu in the ocean are consuming the nutrients, a specific type of nitrogen called N15. So they analyze the tissue, and sure enough, they're eating the nutrients. So this begs the question, what are the Limu? They're like the life support system of the ocean, and they're like the custodians. So when there's an imbalance, they show up and try to clean it up, but in the process, smother the reefs. So it's like a good thing out of control. Same thing in Lahaina, we've got elevated in 15. So how much nutrients, like Miracle Grow, is going into the ocean? Over 300,000 pounds per year. So over 100 tons into the ocean. Okay? And that's about 4 pounds per person who's on the network. So what is wastewater? It's basically the equivalent of surface water that's being polluted and concentrated into one place. It's about the equivalent of a stream. So what do the streams do? They're full of photosynthetic life. I saw your images had some green in it too. Yeah. The streams are actually self-cleansing. They're consuming nutrients as the water flows. So The Limu are kind of a special thing, okay? So you can see this is Waiahui Stream in East Maui. Okay. So what if we took a stream and we created basically a man-made stream that cultivates this Limu in a way that make it proliferate a lot and consume pollutants? So this is called an algal turf scrubber. It's on a pier here, so it's kind of confusing. This is water. But the algae are basically attached to a mesh, and the headworks creates a pulse, so it creates turbulence and mixes the algae so they like to grow. So you can scale that up to several acres and basically make a man-made stream bed growing Limu at several acres in scale. And that can receive all the water safe from Kihei. So this is a close-up of an experimental system. You see the mesh where the algae attached to. The headworks creates like turbulent flow, and on it grow the algae. Okay. Here's a close-up of the mesh, and it's actually several different types of algae typically. Sometimes you'll get insects, and it's almost like a little reef itself. Okay. Here's some close-ups of the algae. I think they're really beautiful. And here are some close-ups of native Maui stream Limu. Now when you magnify them, they're actually quite beautiful. Some of them look like they're made of glass, they're colorful, and have all these unique shapes. This is Limu from Waiahui. It's Chlorophyta rhizoclonium hieroglyphicum. So it wasn't named on Maui. These are found in other places in the world. But I'll pass this book around. I've marked the page that has that Limu, but if you guys want to look at it an hour later. But it's beautiful. I believe it's sentient. That's debatable, but you know, algae created our atmosphere that we breathe. They're the source of all petroleum products, water plants, and something most people don't know is when they created all that oxygen billions of years ago, they actually oxidized the minerals. So the majority of minerals on Earth and the crust were created by oxygen from Limu. So they actually formed our planet for us. So they're major players in life support. This is the headworks of a large system. This is the siphon break serger that creates pulses of water to go over it. Okay. Again, a large-scale system. This one was done in Florida. So how much algae would you need? I've done some estimates, and at about a gram or two of nutrients per meter squared per day, you're going to get 7 to 10 acres of algae. Now that sounds like a large area to pave to make a stream bed, but it really is a matter of priorities. We pave 12 acres to go and target when you don't really know what you want. You just kind of wander around. 20 for Maui Mall, 42 for the Queen City Center, so this can be done. It's not like a huge deal to pave 10 acres to save our reefs. So we get a lot of biomass from this, 50 to 100 acres, or tons per a couple of acres per year. So what can we do with this biomass? We can compost it and use it in our agriculture, and it grows better than peat moss. So what do we do with this water once we've cleansed it? So, okay, 100% algae grows really well, even better than 100% peat, and this is a blend. So it's an experiment that shows it's very high value potency.
Color looks richer too.
Yeah.
Stronger and everything.
So what do we do with all that water? You know, reuse is like the obvious solution, but the problem with that is you need to develop customers, you need to build the resorts, build the golf courses, build the pipes. So why don't we just build a giant forest right there next to the wastewater facility? Precludes the need for huge infrastructure to redistribute the water, and you know, in this drought, we just need as much green as we can. So, but the 4 trees I've identified are to grow are ohia, ahalee, sandalwood, and koa'ia. Those are the first 4 that we've started to plan for our test. So one more. How big of a forest would it need to be? Well, the Reef guidelines say that it has to be as much water as the plants can evapotranspire, so evaporation and transpiration through the plants. And it also can't be too much nutrients for the plants to uptake. So if you take it from the transpiration, it needs to be around 200, but look at the nutrients. Once we reduce the nutrients from the algae, you can, you know, you're not driven to distribute the water over this huge area. You can put more water on a smaller area. So that's why we don't make a forest with our current reuse, because it would have to be 300 acres or more with the current levels of nutrients. So when the algae take down the nutrients, you can reuse the water more generously. Okay? So how big would this be? This is about 10 acres, so you can see it's about the same size, smaller than the existing facility. The forest, this is 70 acres, I'm estimating more like 100, but it's not like this gargantuan area of the landscape to do this. So, actually on the previous slide, can you go back?
What was that land?
Haleakala Ranch. I met with him. He was not exactly a representative. He wasn't exactly enthusiastic about the idea of receiving water, but he did in earnest say he wants to see the results of my experiment. So it's not a completely closed door. Yeah. All right.
Are you working with someone to make it like a native forest?
Yeah, Plant a Wish, which is an organization. My friend, he's my tree guy. I already hired him, so he's going to organize that. And yeah, I've received. Oh, go ahead.
Well, I was going to say that if you planted, instead of strictly native trees, plant fruit trees, because then it could be native fruit trees, and then you're going to get rid of more of your nutrients.
Yeah, I've thought of that. I always get stopped at the yuck factor of using wastewater for food. I don't know if other people have that.
Well, if you use it on trees, they're not wastewater.
Right.
Never happens to anything with the fruit.
Right. So when you're also putting it through the algae, which is kind of like another treatment step. So it's definitely in my mind, and I've always kind of gravitated to a breadfruit because it just resonates with me. But yeah, we're going to test out how it grows. But
Is this similar to the Africans project that we're going to use this weekend?
What is it?
That Africans in Waikaku, his sweet plant.
Oh, the Organica?
It's similar to what Hungary uses.
Yes, that's Organica. So that is basically a secondary treatment system that uses plants, and it basically does not quite as good as our existing wastewater treatment facilities. So what's good about the Limu is, the facility takes out the 80% of the raw sewage and leaves 10 to 20%. And that last chapter is very difficult to get out, to get below, like, say, 3 milligrams per liter. So, okay. Does that answer your question?
Yeah.
Okay. All right, go ahead. One more. And so, yeah, this gives you an idea of scale. So my estimate is that the size of the forest needs to be somewhere between Maui Golf Course and Nine Meadows, so about 1 to 200 acres. How much is this going to cost? Well, a lot, but compared to what? So the county says that an ocean outfall to take the wastewater further into the ocean as their solution is several $100 million per facility. I've heard a rumor that people think it's going to be $1 billion to eliminate injection, but I think you can do it for $4 per visitor for 10 years. It is $100 million, but the solutions they're talking about are in the hundreds and hundreds and hundreds of millions. So again, it's just a matter of priorities. And we have $5 billion in revenue from tourism every year.
Is that, I'm sorry, is it $100 million one-time cost, or is that?
For everything, yeah. For the algae and the forest at each site, but in Kahului, you actually have to upgrade the facility to the standard that the other facilities are at, because Kahului is like 3 times as much nutrients as the other facilities. The level of treatment is much lower. So you have to upgrade the facility there first. You actually have to get it to the point for the algae.
So we're talking about using R1 water.
Take R1, take the nutrients out of it, and then you grow a forest. So if you tried to just grow a forest with the nutrients in it now, in 10 years you would have put about 200 tons of nutrients on that forest. So it's nutrient laden. It's not the best to put it for the reefs on the landscape.
And so by the time it reaches our ocean, what kind of water is it?
Well,
It's still R1 water.
Well, R1 doesn't have any specification for nutrients. It's BRD, biological oxygen demand, total suspended solids, and how well it's disinfected, but there's no nutrient standard for R1. So, but yeah, would it still be R1? There's still some debate because would it still be disinfected after we
Yeah,
process
it's
it?
still up our reefs.
Well, it's going to have a lot less nutrients, and it's not going directly into the groundwater. So more treatment and diversion. So, I mean, the water has to go somewhere.
Of course, yeah.
So Robin Knox always says, redistributing the water doesn't solve the nutrient problem. It makes it harder to solve. Because you have a point source, it's in your hands, then you let it go.
Yeah.
And it's everywhere. So more treatment and the same disposal method.
Yeah, so we like diverted to Maui Resource.
Yeah.
Oh, there's a solution.
We'll just mail it to them.
Yeah, we pay for that DT, bro.
So have you talked to anybody in the government about the flesh fee and the Department of Taxation, like passing a law to create a flesh fee?
Well, I testified about it a few months ago, and now I've heard that environmental fee is like a buzzword. So I'm not going to take credit for it, but it's definitely an idea that's out there.
But that would be the state level or the county level?
I'm not a tax person.
Where did you testify?
County council
Okay.
in May, and now
Okay.
a couple times recently.
I like the flesh fee because if you're gonna bring your stuff here, you might as well.
Well, it's done in near the Chesapeake Bay, and one county raised like $100 million, but they charge the residents. See, we have this big pool of visitors we can charge.
Charge them.
Yeah, that's what I'm saying.
Like a toll road.
Huge hole.
A one-way road.
Okay. And I got a grant from the Born and Raised Earth Foundation for $100,000, which sounds like a lot, but it's not a lot to do anything for 18 months in Hawaii. But I'm working with some collaborators out from the Smithsonian who are going to come out and build a pilot system. It'll be about 100 feet long and 2 feet wide, and we'll have intermediate bulk containers like reservoirs. We'll fill them with wastewater, recirculate it for a day, and then water the trees, and just repeat that every day. And it's just a microcosm of what you would have to do at scale. So you want to improve the biology. It's all about the
So is
biology.
it going to be trees that like brand new trees?
Yeah, brand new trees. Yeah. So it's just desolate land over there.
Yeah. Wow, that's going to be cool.
And we're at a crossroads. Maui County can be the county that opens the door for polluters, or we can have the best nutrient-neutral wastewater system in the world. I really want kids who come here in the future, where their watershed is broken, they live in wastelands, to come here and be inspired to go and do careers to help their home. So I really think that it's a very critical time in our history, and we need to do the right things. That's it. And this is my handle for the problem.
Thank you.
Oh, and here's Algae if anyone wants to see it later. Who does? Yeah.
Well, this is the island.
My name